In this video, we're going to talk about how to evaluate the derivative of a cotangent function. And the process for evaluating the derivative of a cotangent function is as follows. So, the derivative of cotangent x is equal to negative cosecant squared x, or a more intuitive way of looking at it is the derivative of cotangent x is equal to negative cosecant squared x dx, which is to say the derivative of cotangent whatever. It could be x, it could be y, it could be a whole bunch of other variables, is equal to negative cosecant squared blank, okay, whatever was in this box here, times the derivative of blank, which is whatever the derivative of whatever was in here. So let's demonstrate that with an example here. So let's say you're given a function f at x is equal to cotangent x cubed. And for this example, I'm assuming that you are comfortable with the power rule. If not, I have made a video about the power rule, and I'll link it to this video for your reference. So how would we evaluate the derivative, can't speak today. How would we evaluate the derivative of f at x? So we would just follow those steps as listed above. So we write f prime at x is equal to, okay, so we have cotangent, so we'll write cosecant, okay, cosecant squared, or negative cosecant squared, blank. So what is blank? In this case, that is this entire term here. Okay, so that'll be cosecant squared x cubed times the derivative of whatever blank is. Okay, the derivative of whatever was in this cotangent term. Okay, so the derivative of x cubed would be, using our power rule, 3 times x squared. Alrighty, and yeah, there you have it. If I wanted to as well, I can also bring this 3 up front and, you know, clean it up a little bit. But we're just going to move on to the next example, which is you're given a function g at t. Okay, we'll call this function g at t is equal to cotangent of cos 3x. Now, for this example, I am assuming that you are comfortable with evaluating the derivative of a cosine function. If not, I have made a video about that, and I will link that in this video for you guys to take a look before coming back to this question. In the meantime, I'm going to go ahead and proceed with evaluating this derivative. So in order to do that, again, we'll follow the exact same steps. So we'll go g prime at t is equal to, okay, cosecant squared, negative cosecant squared, times this blank here, so whatever was in here. Okay, in this case it's cos 3x. So we'll write cos 3x times the derivative of blank, okay? The derivative of what was in here. So the derivative of cos 3x, okay? And as we've learned from the previous video when we evaluated the derivative of a cosine, the derivative of a cosine is negative sine. Okay, negative sine 3x. And then again, we would evaluate the derivative of whatever is in this little box here and multiply that. And the derivative of 3x is just 3 here. Okay, so to simplify this, the two negative signs cancel out. And then what I can do here is I'll just bring the 3 out front here to make it look a little bit prettier. So the negatives cancel out and it's a positive. We'll get 3 times cosecant squared cos 3x times sine 3x. All right, and there you have it. So there is the answer. What I'm going to do is I'm going to take away this bracket just to make sure it's not as confusing. Sine, and I'll write it like this instead, just to make it less confusing. Okay, so there you have it. That is how you evaluate the derivative of a cotangent. In the next video, we're going to talk about the derivative of a secant function. Thanks for watching, and we'll see you in the next one.